Remember, exponent to exponent, they multiply each other. So in this case, 2 times 3 is how much? 6
6.
multiplied. And then here we have 3 times negative 2, which is going to give us negative 6. Correct?
Yes.
Yeah.
And then now finally, remember, if ever you multiply the same basis, what happens with the exponent?
If the exponents, they stay the same.
No, whenever we multiply the same basis, the exponents are added, right? So you're going to have
Oh,
6 plus
sorry.
minus 6, right? 6 plus minus 6. Let's quickly check how much will that give us. Put anyone who has a calculator with them, which all of you guys should be having your calculators with you now. Quickly check how much that gives us. Quickly check. Uh, 6 plus minus 6. How much that is 0, right?
Yes.
So in this case, you're going to have 2 to an exponent of 0. Anything to an exponent of 0 is how much?
1.
It's 1. So now which one is our answer there?
B.
It's B. So let us remember all those small details. And then coming to 17. 17 again here we are given. And remember I said from 15 upwards, we are going to work. Yeah, 15, from 1 until 15, yeah, there you can use calculators very easily, but from 15 upwards, they want calculations. So here we are given x exponent of negative 3, y over negative 2x exponent of negative 2, close bracket, we have negative 3. And then again, remember, if ever we have an exponent to an exponent, what do we do?
Multiply.
We multiply. So here we're going to have x, negative 3 times negative 3 is how much?
Negative 3 times negative 3. Positive 3. Or positive 6. Sorry.
It is positive 9. Khona wena kuyisa grade 3
Oh,
wena. Negative 3
Jojo.
times negative 3. It gives us positive 9, right? And then what is the exponent of
Yes.
y here? It is 1, remember? So now this one also it has to get multiplied there. So 1 times negative 3 is how much? Negative 3 over. And then again here, remember that exponent is for everything inside, right? So negative 2, the exponent of it should be negative 3 because we have a 1 there. So that 1 times negative 3 is negative 3. And then here again, we have an exponent to an exponent. Negative 2 times negative 3 is going to give us how much? Positive 6, right?
Mm.
Yes. And then we continue again. So now when you get to this point, we have x divided by x. What happens with the exponents there? If ever we divide the same basis, what happens with the exponents?
We subtract.
They subtract. So we're going to have x 9 minus 6. Does this negative 3 have the y? Do we have any y below on our denominator? Can we
No.
put y? So we're going to keep it just like that, right?
Yes.
Yes. And then remember, if we have something like this, 1 over 2 exponent of 3, how can we write this thing? We can simply write it as 2 exponent of 3 over 1, right? The only thing that changes now, if we write it on the numerator, if the sign was negative, now the sign is going to be what? Positive.
Positive.
So now, meaning this negative 3, 2 with an exponent of negative 3, we can write it as 2 exponent of 3. And then remember, this y here, if ever we want to write it as a positive, because you can see that the exponent there is negative, right? So if you want to write it as a positive, how do we write it if we have something like this? We can write this as what? 1 over y exponent of 3, right?
Yes.
So instead of us writing it on our numerator, we're going to write it where? At our denominator. So we're going to write it there. In fact, let me use a different color. We've been using blue. So let's write it here. And then remember, we still had that negative. So the negative will always be there. So 2 with an exponent of 3 is how much? Let's simplify now. 2 exponent of 3 is how much? Is 8.
Mm.
We have x. 9 minus 6 is how much?
3.
Is 3. And then over y exponent of 3. So which one is our answer in this case?
Um,
It's
Answer is
A.
A. Our answer is A.
yeah, so can I quickly write it down first before we move on to the next thing?
No.
Now you have a recording, man.
Mm.
I just recorded,
Yes.
so you will have access to it.
That's about technology. Okay.
Thebo kwemepilo we. And then here we have another one. We are given 3x plus y exponent of 0 over y plus 5y exponent of 1 minus x exponent of 1 y close bracket exponent of 3 x negative 3 y exponent of 4. So now remember, if ever we have anything to an exponent of 1, to an exponent of 0, how much is that? If it's something like this,
0.
it's going to give us how much?
0.
Seboko bese.
0.
Is that 0? Anything, remember, anything to an exponent of 0, even if we have 20 to an exponent of 0, is going to give us how much? 1
1.
all the time. So now, in this case, we're going to have 3 multiplied by 1 over y plus 5. Remember, if we have this thing as a negative, how do we write it? Where do we write it for us to make it positive?
Under.
Yes, we're going to write it as a denominator, right? So we can make it positive. So it's going to be y positive 1 because it was negative 1, right? So it's going to be positive 1 now. And then we have minus. There again is going to multiply. So negative 1 times negative 1 times 3 is going to give us negative 3. And then y again, there's 1, is going to multiply, there's going to give us that over x exponent of 3, y exponent of 4. So now finally, at this point, we're going to have 3 over y plus 5 over y. Now here, if ever we divide the same denominators, what happens? If you divide the same decimal, the same exponents, what happens?
We add the
They cancel each other out, right? So this is going to cancel that out. And then here, we're going to have y, 3 minus 4, correct?
Yes.
But this has to come up. But if it was positive, now it's going to change sign and becomes what? Negative, right?
Negative.
Negative.
So now this is going to give us how much? Quickly. 3 over y plus 5 over y minus, here's going to give us y negative 1. Y negative 1, we said, how do we write it?
We take the negative y
It's going to be 1
1
over
over y.
y, correct?
Yes.
So now looking here, at this point, do we have the same common denominator? Do we have the common denominator here?
Yes.
Our denominator is what? Is y, correct? So if we have a
Y.
common
Yes.
denominator that is the same, we can simply write it alone. And then we have 3 plus 5
5 minus
minus
1.
1, which will then give us how much?
Give us 7.
7. 7 over what? Y.
Y. Over Y.
So what is our answer?
D.
Our answer is D. Correct?
Yes.
Yes.
Yes. Okay, let's continue. There's this person. Okay, thanks. So now, for this one, we're going to patterns now. For patterns, we have pattern. It is 3, 8, 15, and 24. What's the next term on this pattern?
The next term is 35.
Is it 35? What's the
Yes, sir.
difference? Here we have 5, right? We have
Yes, sir.
5. Here we have how
Then
much? 7.
7,
And then here we
9,
have how much?
9.
9. So the next one, how much should we have there on top?
We should
11, I
have,
guess.
yes,
Because you can see we have 7, 9, 5, 7, 9, 11. And then here is going to give us how much? 35. So our answer for this one is,
it's B.
yeah, 20. They're saying here, how many stars do we have on the first pattern? 3, right? Here,
Yes, sir.
how much? 6.
6,
And then here, how much do we have?
9,
Is it
10,
9?
10,
Yes, 10.
10.
So on the next pattern, how much are we going to have? Pattern 4. How many stars are we going? Let's see. Here we had 3. There's 4. Meaning here, we're going to have how much?
6,
5, I guess. So
16.
for pattern 4, we're going to have how many? 15. I guess. Pattern 6. How much are we supposed to have here on top? If we have 3, 4, 5. Here, how much should we have?
6.
6. So 15 plus 6 is how much? 21. Correct?
Yes, sir.
So now let's check if we have such a number. Do you have such a number?
No, isn't the pattern wrong?
No, I skipped something. Remember, I have P4. This was supposed to be P5, not P6. So this one is P5. And then now, here we're supposed to have how much? 7, right? So 7 plus 21 plus 7 is
21,
28.
28, which is
So
D.
P6 is how much?
28,
It is
D.
D. Stop rushing to say the question papers are wrong. Check first if you are not the one who's wrong. Because when I can say, like you like running that direction. No, say this thing is wrong itself. And sometimes it's us who are wrong. So be patient in that aspect. And then they're saying here, which statement best describes the pattern? Before we go there, let's find the pattern first. Here we have 1, and the next number is how much? Let's say 2. Here we have how much? This is 6. This is how much? So that pattern doesn't work. So now let's check the ratio. A constant ratio is used. How do we check the ratio? We take the ratio by taking the second pattern, the second pattern, or the second term, we divide it by 1, right? By the first one. How much does it give us? It gives us 3. Then we take this one now, we divide it by that one. So let's check. 9 over 3. How much does it give us? 3.
3.
Then now we take 27, we divide by how much? By 9. Let's check how much it gives us. 27 divided by 9. It gives us 3. So are we having a constant ratio in this case? Is this thing a ratio? This is a ratio, right?
Yes, sir.
So in this case, is this number constant?
Yes.
So our answer is a constant ratio. A constant
Mhm.
ratio of 3 is used. How much is
Mhm.
that? How much is our ratio? Our ratio is 3, right? Which is that number
Mhm.
that which we got there. Then 22. And remember I said for this one it's quite easy. Don't work too hard for such questions as 22. They're saying, what is general term of the relationship represented by the table below? Take the first one, test it. If you put n here as a 1, do you get a 5? Let's quickly check. Tn is equals to 4. At the place of n, I'm going to put that 1. And then it still has plus 1. How much are we getting? Is it 5? Yes, it is 5, correct?
Yes, sir.
And then let's take the second one now. Let's say Tn is equals to 4. At the place of n, I'm going to put 3 now, plus 1. Are we getting a 1?
No.
No.
So meaning this one is not what? Is not correct, right?
Yes.
So now we're going to test another general term or yeah, general rule or whatever. So for B, we take this one, we have Tn is equals to -4. At the place of n, I'm going to start from scratch again. You put 1 plus 9. How much do we get? Do we get a 5?
Yes.
Get a 5? Yes, get a 5. And then let's check when you put a 3, how much we get. We have -4. Now you put 3 plus 9. How much does it give us? -4, open bracket, we have 3 plus 9.
Give us negative
-3.
-3. Is it correct?
Yes,
Yes,
sir.
sir.
Yeah, we're supposed to get a 1, but we're getting -3.
Yeah.
Correct.
So it's not
It's not
correct.
correct.
It's not correct, right? Then we start again
Yes, sir.
from scratch. We look for another one. I'm going to C now. C, it says Tn is equals to -2n. At the place of n, I'm going to start again from scratch. You put 1 plus 7. Do we get a 5?
Yeah.
Yes, we get a 5. So the first one is correct. And then the second one, Tn again, -2. At the place of n, we put a 3. How much do we get in this case? Are we getting a 1?
Yes.
Okay, we get a 1. Let's see again. If we put a 5, if we put a 5, let's see if we get -3. So we have -2 exponent of 5, times 5 plus 7. How much do we get?
-3.
-3. So again, this is correct, that is correct. Let's check the last one if it's correct. Now we have -2, 7 plus 7. Quickly check if you get a -7.
Yes, we got a -7.
So which one is correct now? C is correct,
C.
Mhm.
all right? So now that's how we attend to this one. And then coming here, they're saying which of the following are like terms? How do we see like terms? We see like terms by the variables, right? The variable as well
Yes,
as
sir.
the exponent, correct? So
Yes,
here
Yes,
sir.
sir.
given 3x cubed plus 3x times x squared plus 3x squared plus 3x. Before we do anything, let us simplify this term here. This one, let us simplify it before we do anything. We're going to have 3x cubed plus 3x times x. What do we do if we multiply the same basis? We add the exponents, right? So 1 plus 2 is how much? It is 3. Then this one is already simplified. 3x squared plus 3x. So which ones are like terms here? Are these two like terms? This one here and that, are they like terms?
Yes.
They are like terms, right? because
Yeah.
if we simplify this one here, it gives us a variable with an exponent of 3, which is that one and that one. So our A is correct. And then on 24, they're saying what is the coefficient of the variable and the degree of the term. What is the coefficient here? Remember, a coefficient is what? Is a number multiplied to x, right? So how much is that number multiplied to x?
2,
It's
negative 2.
2, right? It is -2. -2 is our coefficient, and they did not want only the coefficient. They said they also want the what? The degree. How do we find the degree? Let us solve this first. 2 times 3 is how much?
2 times
2
3
times
is
3 is
6.
-6.
6.
It's 6, right?
Yeah.
So the degree here is how much?
-6.
Our degree is 6th degree, right?
Yes.
Yes. But now in this case, we don't simplify. We just look at the x there, and then we check. Here we have -2, and our degree is what? 2nd degree, which is that one there. In fact, before we do that, did we simplify this calculation? Did we simplify
No,
it?
sir.
So firstly, before we answer anything, what are we supposed to do all the time? We simplify first.
Simplify.
So let us simplify quickly. So we're going to have -2 exponent of 3 x exponent of 2 times 3, we said is 6, right? So now finally,
Yes, sir.
-2 with a 2 cubed is how much? It's 8. So what is the coefficient of x? What is the coefficient of x? Hmm?
-8.
-8. What is the degree of x?
6.
It's 6. So our answer in this case is what? It is D.
D.
Remember, all the time, before we do anything, let us simplify first. All the time, simplify before you do anything. And then coming to this one, they're saying, which of the following is a trinomial when simplified? Which is a trinomial here? Remember, trinomial must have what? A variable has to have what? A square,
A squared.
plus or
It's
minus
B.
1, I guess.
Yes.
And then we have a constant term, correct? So what are we
Yes, sir.
having for this one? We have a square. We also have a what? A square. Is it trinomial?
No.
No.
No,
It's not.
No.
Here we have a
it's
square. We
B.
have a square. Is it trinomial?
Yes.
Hmm?
No.
No.
It's not. And then here we have a square. We have an exponent of how much? Of 1. And we have a constant term. Is it trinomial?
No.
Why?
Yes, the trinomial because there's x squared and a constant different and x with the exponent and 1, which is C.
Yes. So here we have exponent of 2. We have exponent of 1. And we have a what? A constant term. So our answer is C. For D, do you have a squared?
No.
So it can't be it can't be what's this thing? A trinomial. It can't be a trinomial. And then here they're saying we should simplify. Simplifying here, what do? We multiply in here, right? So negative
Yes,
times positive is going to give us negative. We have 1 there. 1 times 4 is 4. x times x squared is going to give us x cubed. Remember, we add the exponent. So that was the first one. The second one, we come here now. Negative times positive is going to give us negative.
Negative.
1 times 2 is going to give us 2. X times x is going to give us x squared. We're done. Then we're going to for the last one there. Negative times negative is positive.
Positive.
1 times 1 is 1. X times nothing there is x. So which one is our answer here? Is it the first one, the second one?
A.
It is A, right?
A.
Mhm.
Remember, if we have a 1 there, we can simply remove it and be left with x. Or if you want, we can put it. But if we don't want to, we can simply remove it because we know we have a 1 there. So remember that. And then coming to 27 now. Again, they're saying we should simplify. How do we simplify? Again, we go in there, right? So 3x times x is 3x squared. And then again, we go there. We had a positive there. So positive times negative is negative. 3 times 4 is
Negative.
12. And then x. Then we still have plus. Here, let's simply do it this way. We have 4 over 2 plus 2 over 2. We just broke this thing down. We just broke it down in that point at that point. So let's quickly finish it off. We have x squared minus 12x plus 4 divided by 2 is how much?
4x.
Yeah.
True.
2 divided by 2 is how much? 1,
One.
right? So finally, do we have any like terms at this point?
Yeah.
Those are like terms, right? Because
2x
the exponent there is 1 and also there is 1. So 3x squared minus 12 plus 2 is how much?
Minus 12 plus 2.
It's 10. Negative 10.
10x. Yes, negative. It should be negative, not positive. It is negative 10x. And then you have plus 1. Correct? So which one is our answer at this point?
A.
It is A.
Ah.
And then we have 28 and 29 and so forth. Again here, just a quick tip. If ever we have 3 cubed, we have 0.125 x cubed. Simply remember, what is the exponent of this number here? Of this number here. What's the exponent there?
Is it 3, sir?
No, the exponent there is 1. Right? So what do?
Oh,
We
sorry.
take this outside. We write this one the way it is 0.125. Then we have 1 over 3. Where does this 3 come from? It comes from there. And then we have x, this 3 over that 3 outside there. And quickly check when you put this in a calculator how much you get. So we're going to have 0.125, 0.125,
It's B.
1 over 3. I'm coming now, table. So we have a half. So we have a half. X, 3 over 3 is 1, right? So our answer
Yes.
here is what?
B.
Nope. Remember I said if we have this thing on the side, where else can we write it?
On top.
Yes. So we're going to have what? X over 2. Remember, if
2,
we want to, we
which
can
is
have
A.
1 there. But if we want to,
Which
we
is
might
A.
simply remove it. So our answer is
A.
A. And then number 9, 29. Again, simplify here. What is the product? When we multiply this and that is going to give us what? 2x squared. We multiply it there again. It's going to give us what? 1 minus 3 over x. Now we come to this one. We multiply here. It's going to give us 6x. Then we multiply there. It's going to give us negative. Is it 3 or is it 1? It is 1, right? Why is it 1? What do you guys remember of this thing? If you multiply, this is a what is an inverse. And remember, if you multiply them, they should give us how much? A 1 there. So please don't forget that. Don't forget it. So finally, we have 2x squared. Do you have any like terms? We do have like terms, which is that and that.
Yeah.
Remember the exponents there is 1 and 1. So all the time, please don't forget to look for like terms. All the time. Don't forget to look for like terms. So here, we quickly go to our calculator. We have negative 1/3 plus 6. It gives us how much? Plus 17/3, right? And then you still have an x minus 1. So our answer is which one now? Our answer
B.
is C.
C.
All right. And then on the last one, what is the numerical value of this thing? If x is that much, so we're given negative 8 x squared plus 10y minus 2. So they're saying if x is a half, so we're going to have negative 8. At the place of x, we're going to put how much? Negative 1/2 squared plus 10. They said y is how much? It is 2. So at the place of y, we're going to put 2 minus 2. Then you put this thing in the calculator and check how much you get. So quickly, we're going to have negative 8 half, then plus 10 times 2 minus 2. And then our answer in this case is 22, which is
B.
right. So now, like I already said, you guys in the next 30 minutes, you're going to do from 31 up to 45. In the next 30 minutes, I'm going to do 31 up to 45. Those that don't have the question papers, I will send the question paper again in the WhatsApp group. And then you guys do that remaining. And then at 7:10, we'll be doing the second part where we'll be doing from 30 until 45. And then this the recording, I'll give it to you guys on YouTube as soon as we're done with everything else. Is there any question?
No, sir.
Okay. Good luck, all the best. Send your work latest at 7:15. We're doing from 30 and we're doing from 31 until 45. From 31 up until 45. I'll send the work just now for those that don't have the work. Okay? Thank you so much, guys.
You're welcome.
Thank you, sir.
Sharp, sharp.